like sine omega naught t ut. I think it is omega naught by sine omega naught ut. It is omega naught by and cos omega naught t ut. That is s by s square plus omega naught square. And this is real. Both ROC is a real part of s greater than 0. And I think you must have solved this type of problems in your mathematics course, isn't it? Have you done this type of problems?
Yes, sir.
So do I need to explain it? Okay, so anyway, I'll explain one or two problems. So this one, and the proof of this is also straightforward. We know the standard result, e to the power minus at ut, that is 1 upon s plus a. So sine omega naught t, it is e to the power minus j omega naught t plus minus, minus e to the power minus j omega naught t by 2j. And if you apply that properties of Laplace transform, you will get this result. Okay. Now tell me what is the answer of 1b? E to the power minus 4t ut plus e to the power minus 5t sine 5t. Okay, there is a typo in that question. It is e to the power minus 5t sine 5t ut. Okay. What is the Laplace transform? The first part is 1 upon s plus 4, and the ROC is real part of s greater than minus 4. And what about this? What about this sine phi t ut? Sine phi t ut, if you use this result, it is 5 by s square plus phi square, and the ROC is real part of s greater than 0. Okay, this one, only this part. Now what will happen if you multiply with e to the power minus 5t? That is the frequency, that shifting property. There is a property, if you e to the power s naught t xt, that is x of s minus s naught, isn't it? Okay. So then what will be this one? You have to replace s with what?
S plus
S
5.
plus
So this would be 5 by s plus 5 the whole square plus 5 square, isn't it? What will be the ROC?
Real part of s greater than minus 5.
Real part of s greater than minus 5, and when you take the intersection, the complete ROC is what? Real part of s greater than minus 4, isn't it? It is intersection of these two. This is s greater than minus 5, and this is minus 4. So it is that. Okay. So that is the answer. Okay, one more question. Let's say E part. Xt is equal to mod t e to the power minus mod t. Okay. Can we convert it into some standard form? What we already know is e to the power minus at ut, that is 1 upon s plus a, and real part of s greater than minus a, isn't it? Can we write it in terms of this? Can we write it as, what is the expression for this signal for t greater than 0?
T e to the power minus 2t ut.
It is t to the power minus 2t ut plus, what about the negative part? Plus or minus?
Minus
T
minus t e to the power 2t u minus t.
minus t e to the power 2t u minus t, isn't it? Okay. Now what about this? E to the power minus 2t ut is 1 upon s plus 2 and real part of s greater than minus 2. What is this property? Multiplication with time. There is a property, you can see that formula sheet. The property is that txt, that will be derivative of d by ds. It is the differentiation in the s domain. Okay, I think there is a minus sign somewhere. Is there a minus sign?
Yes, sir, it is minus txt.
Minus txt. Okay. So what about this? What about the Fourier transform of the first part? This is s plus 2. When you multiply with t, is it derivative of this? So will you get this 1 upon s plus 2 whole square? Because when you take the derivative, there is a minus sign. There is a minus sign here. So that will get cancelled. So 1 upon s plus 2 whole square, isn't it? Is it?
Yes.
What is the ROC? What is the ROC? What is the ROC of this? Real part of s greater than minus 2. What is the ROC of this? Is it same? This is a right-sided signal, real part of s greater than minus 2. If you differentiate it right-sided signal, what will be the signal? Is it right-sided?
Yes, sir.
So this will also be, pole is at minus 2. Location of the poles won't change. There is another pole at the same location, multiple poles. Okay. So this is also real part of s greater than minus 2. Now what about this part? How is it related with this? This one?
T equal to minus t.
Put t equals to minus t, you will get this. So what is the property?
Reflection.
Reflection. Reflection, what will happen in the s domain? 1 by what? What is the property? If xt Fourier transform x of s, x of minus t is x of minus s. So what will be the, Laplace transform of this? Minus t e to the power 2t u minus t. If you put t equals minus t, you will get this one. So will it be?
Minus s plus 2.
And you can also write it as s minus 2 whole square, isn't it? Is it? So what is the final answer? Is it 1 upon s plus 2 whole square plus or minus?
So plus.
Plus. And what about the ROC? What is the ROC of this? This is a right-sided signal. When you flip it, what is this property? Is it real part of s? What? Less than 2? Where is the pole? Pole is at 2, isn't it? For this signal, there is a pole at minus 2, and if you flip the signal in the time domain, this will also be flipped. This is the pole. And this corresponds to a right-sided signal. When you flip the signal, the resulting signal is a left-sided signal. So the ROC is real part of s greater than 2. So what is the combined ROC?
Minus 2 to 2.
It is real part of s between 2 and that is the answer. And other problems are also similar. Okay, just one more question from that. What about this delta t plus ut? This is a standard result given in formula sheet. What is the Fourier transform, Laplace transform of delta t?
1.
1. And ut is 1 plus s, 1 by s, isn't it? And what is the ROC? Delta t is the entire s plane. This is real part of s greater than 0. Okay, that is the ROC. Now, what about this? Next question, delta 3t plus u3t. Can you use the some property here? So this would be s plus 1 by s, isn't it? What about this? What is its shifting property? X of at is what? I think it is 1 upon mod a
Mod A X E.
x s by a. Okay, so you can using the shifting property you will get. Okay, this is an interesting question. Interesting because what is the relation between ut and u3t?
So both are
Both are
Same.
same. Both are same, isn't it? Is it? And what about this? Are they same?
True, sir.
No, they are not the same. There is a property delta at if you scale delta function with a, then it is okay. Delta at is not same as delta t because and you can find it from this. We have considered delta function as a limiting case of I don't know. I think I have explained both rectangular function and triangular function, isn't it? Okay. So this area is 1. What will happen if you delta at, then what will be the area? It is a limiting case. Delta t is a limiting case of this, isn't it? Where area is constant. You are reducing the width, height is increased. What about delta at? What will be the area? This amplitude will remain same, only this will, if a is greater than 1, then there will be compression. So the area will also reduce by a factor of a. Okay. So what I want to say is even if you apply this property, like the time scaling property here, you will and if you write this as delta 3t plus ut, you will get the same answer. You can verify it. Okay. Okay, second question is finding the inverse transform. It is Laplace transform and the ROC are given. So you have to find the inverse transform. There is one question, 1 by. This is standard result, 1 by s square plus 9. Real part of s greater than 0. What is the ROC? What is the Laplace? What is the signal? What is the standard result? If it is 3 by s square plus 9, then it is sine 3t, right? That is a standard result given in the formula sheet. And if it is 1 upon s square plus 9, then it is sine 1 by 3 sine 3t ut. Okay. So in all these problems, you have to convert it into that the form of that standard results and then find the inverse transform. Can you tell me what is the transform of this? S square plus 9 and real part of s less than 0.
Cos.
Cos.
The cos dt u of minus t.
It is cos.
It's ROC.
ROC. ROC is also important. So if the ROC is real part of s greater than 0, then what will be the signal?
Cos 3t.
Cos 3t.
UT.
Cos 3t ut. ROC is given as real part of s less than 0. Then what is the signal?
So minus cos 3t u minus t.
It is minus 3 cos 3t. Actually, it is minus 3t since cos minus 3t is cos 3t u minus t, isn't it? Is it? Okay. So why this minus sign? Because cos 3t ut, it is s by s square plus 9. So minus 3, my cos minus 3t. Sorry, is this 3 is there?
No, sir.
No, it is not there. It was minus 3t u of minus t. That is, replace t with minus t, you will get minus s by s square plus 9, isn't it? Replace s with minus s. So this is minus s by s square plus 9. ROC is real part of s less than 0. Because this is greater than 0, this is less than 0. Okay. It's got the real part of s greater than 1 by 2. Okay. Can we convert this into some standard form? Can we write this as 1 upon s square minus s plus 1? There will be, this is 2s plus 3s divided by now what about this? Is it in some standard form? These are the results. 1 upon s plus, okay, I think that result is also, yeah, there is a, if you look at the formula sheet, there is a result e to the power minus at cos omega naught t ut. That is s plus a divided by, and similarly for sine omega naught t into e to the power minus at, it is also there. So you have to convert this into this form and find the, you can easily find the inverse transform. Okay, you can try it later on. First, use this result, standard results. Okay. Okay, all those problems are like this only. You have to convert it into some standard form and then find the inverse transform. I think third, fourth, fifth we have already discussed. Sixth is also straightforward. You have to find the okay, in the sixth question, what is the system function? H of s is equal to what? Is it 1 by? Is it this? Is it the system function?
Yes, sir.
So we can write this as 1 by s minus 2 into s plus 1. So the first part is sketch the pole zero pattern. So there are two poles, one at 2 and the other one at -1. That is a pole zero pattern. And you have to find the inverse Laplace transform. That is the impulse response of the signal. So we can use partial fraction expansion. This is -2 plus 1. I think it is 1 by 3 s minus 2 minus 1 by 3 s plus 1, isn't it? Is it? 1 by 3 minus 2 minus, yeah, this one. Now for the three different cases, you have to find the inverse. Tell me what is the if it is a stable system, okay, you have to use the standard result e to the power minus at ut, that is 1 upon s plus a. So tell me what is the impulse response if it is a stable system. Stable means j omega axis must be in the ROC. So this pole must correspond to what? Left-sided or right-sided signal?
Right-sided.
This is a right-sided pole of a right-sided signal and this one left-sided signal. So what is that result? What is that? If this is a right-sided signal, you will get minus 1 by 3 e to the power minus t ut. That is inverse of this. Minus sign is here. And what about this one? Is it 1 by 3 e to the power 2t u minus t? You can compare with that standard result given in the formula sheet. The standard result is minus e to the power, oh sorry, is it minus at or what is that result? No, it is not given. So you can use the okay. This is if e to the power minus at ut is 1 upon s plus a, then what about e to the power at u minus t? That will be minus, isn't it? Okay, so it will be minus e to the power minus at u minus t is, yeah, this is the result, s plus a, isn't it? Okay, this is the standard result, I think. Is it given in the formula sheet? No, it is not given. So using this result, you will get this. The response. If we take the Laplace transform on both sides, what will you get? What is the
We
difference?
get ys by x.
This one is s square ys plus s y of s plus 5y of s is equal to s square x of s minus 2s
X. Yes.
Okay, so you will get HFS what? It is S square minus 2S plus 1
Plus
divided by S square
S
plus
plus S plus 5.
S plus 5. Okay. Now this is the system. Now what is the impulse response of the, this is called the system function. What is the inverse system function of the inverse system?
Reciprocal.
That is S square plus S plus 5 divided by S square minus 2S plus 1. Okay. Now how can we find the differential equation? So can we write this as, let's say the inverse system, this is H inverse, let's say if xt is the input, yt. What is the Laplace domain using this? Can we find it? Can we write it as y of s into s square minus 2s plus 1 is equal to x of s into s square plus s plus 5? Is it?
Yes, sir.
Now, what is the corresponding differential equation?
Instead of YT, there would be XT, and XT, there would
Instead
be
of yt, it will be reverse. Like instead of xt, you'll get the differential equation here. Instead of xt, it will be yt, and instead of yt, it will be xt. Okay, so that is the first part of that question. First question. What about the second part? Is this inverse system stable and causal? This is the system function. Is it a causal and stable system? How many poles are there? It is s square plus s plus 5 divided by s minus
S
1
minus 1 whole square.
whole square. So there are it is there is pole at minus where is the pole?
At 1.
At 1 there is pole. Okay. So can it be both causal and stable?
No.
Can it be
No, sir.
both? No. It cannot be both causal and stable, isn't it? What is the reason? Causal
Because
means,
Either it will be left or right.
yeah,
If it would be right,
both
it
causal
would
and
not
stable,
be.
all the poles must be on the left half of the S plane, isn't it? So it is not a causal and stable system. Okay. So that is fifth question. Okay, I think sixth question, I don't have to explain it. It is a straightforward question. And I think most of you have answered that question also.
Excuse me, sir.
Yes.
So can we comment about its stability?
No,
Because
question.
like
No, question is what is the question? Let me read it out. Is the system stable and causal? It cannot be both stable and causal, isn't it? If it is a stable system, it cannot be causal. If it is a stable system, this will be the ROC, isn't it? It cannot be causal. And if it is causal, this is the ROC. It cannot be stable. So it cannot be causal and stable.
okay, sir.
Okay.